So earlier we talked about DPU, defects per unit. So here we are moving to the next measurement, which is DPMO, defects per million opportunities. But before we understand defects per million opportunities, we need to understand what does this opportunity means. So for that, let's understand what does defect opportunity means. So defect opportunity is any opportunity where things can go wrong. Circumstances in which the CTQ or the client requirement can fail to meet. So those are the defect opportunities where we can miss to meet what client requires from us. Any opportunity where we can fail to meet that would be a defect opportunity. So if you are running an hospital, a doctor, the delay in registration, the long waiting, the wrong prescription, all these could be defect opportunities. These are the things where things could go wrong. So those are defect opportunities. Defect opportunities are related to the complexity of the unit. So if you are making a very simple thing, let's say if you are making water bottle, the empty water bottles, there are 2 or 3 places where things can go wrong. On the other hand, if you are making a very complex system, let's say you are sending a mission to Mars or Moon, in that mission, the opportunities to have defect will be very large. So what does this mean is that the complex unit will have greater opportunities to have defect as compared to simple units. Let's take an example here of a unit which has 5 parts and each part has 3 opportunities of defects. Let's take an example of water bottle. In water bottle, let's say there are 5 parts in that. What are those 5 parts? One part would be the bottle itself, the second part would be the cap, third part would be the washer in that, fourth part could be the seal, fifth part could be the label. So I'm just taking this simple example that in this water bottle there are 5 parts, 5 pieces which can have some or other problem. And let's take a simple example where each of these 5 parts have 3 opportunities for defect, 3 defect opportunities. Then what we can calculate here is that 5 parts multiplied by 3 give us that 15 opportunities. So in this full water bottle, there are 15 places where things can go wrong. So that means there are 15 opportunities for defects. So that's defect opportunity. Now let's take an example from the assembly line which is making these water bottles which has 15 opportunities of defect. We pick up 10 bottles. 10 bottles as a sample and we check these 10 bottles thoroughly. When we check that, we found that in these 10 bottles there are actually 2 defects. So there were 15 places where we could have had defect in each of these bottles. But then out of all these 10 bottles we just found 2 defects. Then what is DPO, which is defects per opportunity? So defects per opportunity will be the number of defects. In this particular case, we found 2 defects, so 2 goes at the top and then the total number of opportunities will be 15 opportunities in each bottle and then multiplied by the 10 bottles which we picked. So that means 150 at the bottom. So 2 divided by 150 will give us DPO, which is defects per opportunity as 0.013333. So this is DPO. And now if you multiply this DPO by 1 million, that will give you DPMO. So in the previous case, we picked 10 bottles. Each of these 10 bottles had 15 defect opportunities. But out of these 10 bottles, we just found 2 defects when we checked these 10 bottles. And based on that, we calculated DPO as 2 divided by 15 multiplied by 10, which came out to be 0.01333. Once we multiply this by 1 million, which we have done here, we end up with the DPMO as 13,333. This is DPMO. Now, what does this mean in context of Six Sigma? In Six Sigma, our target is to have 3.4 DPMO, defects per million opportunities, just 3.4. Against that 3.4, what we got here in this particular example is 13,333. That's a very large number. So that means this is not a Six Sigma performance. The process of making these water bottles is not a Six Sigma process. But then if this is not Six Sigma, at what Sigma level we have 13,333 defects? If you look at the chart, which I will show you later on, you will find out that this particular process has the performance level of just 3.7 Sigma. So next slide, we will look at all these levels. So at 1.5 Sigma, what is the DPMO level? 2 Sigma, 2.5 Sigma. So we will look at that chart on the next slide. But right now, let's understand that in this particular process, the level we have is just 3.7 Sigma as against our target to achieve 6 Sigmas. So this was about DPMO, defects per million opportunities, which you can calculate for any process and see whether your process is in line with Six Sigma performance requirements.